Hi everyone, I am here to write a program in Python to implement this Sieve method. In another video, I have explained how Sieve method works to generate prime numbers in a given range. I am going to implement that idea here using Colab. So first, let me take n equal to 100. You can read it from the user as input, or we can straight away take the number. Then the first thing we have to do is we have to consider a table of numbers like we have considered in the explanation of sieve method. So that table I am naming like primes, and this will be assumed as true, true, and how many such numbers I am going to take? Up to n plus 1. Why I am taking n plus 1 here is it is 0 based index, and we have to go up to 100. 0 to 100 means I have to give 101. So this is the logic behind this. What does this true tell? So each and every position of this primes array or primes list is to be filled with the value true. That means initially I am assuming that each and every number in that range is prime. Later on we will strike off the non-prime numbers. Then one important thing is primes of 0 should be made false. This is not required here, but to be on safer side we can make it like this. Primes of 1 is also false. Then we will start with 2, I equal to 2, and we will be performing this sieve process or striking of process until I square is greater, until I square is less than or equal to n. This is the condition we will check. If I square exceeds n, we have to stop the process. Then if the number is already assumed as prime, if primes of I, for example initially 2 is a prime number, we will start from 2 square onwards, and then for every multiple of 2 we will make the position false. That means we will strike off that position. Like for k in range I square, we will start with I square and we will proceed up to n. As we have to stop exactly at n, I must give this range value as n plus 1. The step value is I. Why the step value is considered as I? Every multiple of I we have to strike off. Starting from I square until n, every multiple of I is to be striken off. So for that reason we are considering the first statement like this. Then if it is a multiple of I, then it can't be a prime number. So make primes of I, sorry not I, that is k. Primes of k equal to false. Then increment I value by 1. Initially we start with 2. Next we will be taking 3 and so on. Increment I value by 1 like this. So with this primes will be updated and some are made false, some are remaining as true. All the non-prime numbers will be made false. Now we have to collect all those prime numbers from this primes table. So for that, for I in range 2 n plus 1, if primes of I, that means if it is true, print I. That's all. You can even store these numbers in a list. We will see that as another variation. So first let me run this code. So what we did in this program, let me explain again. N equal to 100. So I am considering the range 1 to 100. Then I am considering primes array or primes list, which is initially made true for each and every element. So then these two are different elements, primes of 0 and primes of 1. I am making them false. Then we are starting with I equal to 2, and we will proceed until I square is less than or equal to n. If it crosses n, we have to stop the process there. If it is already marked, if primes of I, that means if it is already marked as true, then for k in range I square means if we start with 2, that I square will be 4 onwards. I have explained all this process in Sieve method video. I square n plus 1 I. So the step value here is I. This will help us to track every multiple of I. Then make that position false. Next, increment I value by 1 and repeat the same. So once this while loop is done, that primes array will be containing true value for prime numbers, false value for non-prime numbers. Now we have to collect the positions where it is true. So for I in range 2 n plus 1, if primes of I, then print I. So this will print all the prime numbers in the range 1 to 100. Let me run this code. Yes. 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. etc. 71, 73, 79. Yeah. These are the prime numbers in the range 1 to 100. Okay. Suppose if you would like to store them in a list, we can do like that also. Let me take one temporary list L. If primes of I, what I will do is L dot append I. Then finally print this list. Then we can store the result in a list. The prime numbers are displayed in the form of a list. Okay. Thank you.